I just wanted to share something that I discovered today that I found pretty fascinating. So first of all, this is a piece of software called Stellarium. This is not the thing I'm intending to show you. It's just an instrument to use to show you the interesting thing that I learned today. But Stellarium is free. It is virtual planetarium software. Really super duper cool. You can get it for Mac, for Windows, and even for Linux. So it's completely free, really cool stuff. It enables you to position yourself at any point on the Earth. Right now I've got it set to Duluth, of course. It also allows you to set the date and time to any point in time. So you can see what the sky looked like in the past or see what it's going to look like in the future. Because, of course, all the orbits of the objects are pretty well defined and they're all encoded in this program. Some other really cool stuff you can do with this program is that my current time in the program right now is set to now, so it's playing 1 second every second. But I can hit pause. I can also speed it up and make time go really fast if we want to, or slow it down. Yeah, pretty cool stuff. Also, we can do things like control, turn the atmosphere on or off. So right now, obviously, we're going to see the atmosphere, but if we fast forward to tonight sometime, we're going to see that's going to disappear and the stars are going to come out as they normally would. But we can just turn the atmosphere off all the time too, so that we're looking at it, we're looking at the night sky all the time, even if it's day or night. Some other really cool things about the software, you can turn on the constellations if you want to look at those. You can see the images that are associated with each of these constellations. So like there's the Big Dipper right here, of course, is a part of the larger constellation Ursa Major, the Bear. Again, that's not really what I'm here to show you today. But what I am here to show you is something about exoplanets. And so if you're not familiar with what exoplanets are just simply the planets that are outside of our star system. Any of the planets that are the ones other than Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, Uranus, and Pluto. Which, of course, those 9 planets. Of course, Pluto is it's debatable whether Pluto is a planet. Officially, it's no longer a planet, but I still like to call it one because I grew up in the age when Pluto was still considered a planet. But any planet that is outside of our solar system that does not orbit our star is an exoplanet. And it's reasonable to assume that since our planet or our star has planets orbiting it, that other stars would as well. And of course, there's a lot of stars that we have actually confirmed, or maybe a better way to say it would be we have a strong degree of confidence that these other star systems have planets around them because of observations with very powerful telescopes and other methods. So you can turn that on. You can actually show the exoplanets in this program. So each one of these green dots that has appeared is not a planet itself. It's just telling you that that star that's surrounded by the green dot here, the green ring, that star has planets. It has planets that orbit it. There's even a big concentration over here. So just because we see these green dots here doesn't mean that this is all of them. It just means that we've confirmed that these particular stars have planets around them. And of course, the stars that are closer to us, stars are all different distances from us. Some are, closer, like 10 light years or 100 light years. That's considered relatively close. But some are thousands of light years away. Some are millions of light years away in other galaxies. Of course, and just to recap, a light year is the distance that light travels in a year at the speed of light, of course, which is the fastest thing that we know of in the universe. It's the cosmological speed limit. So what's really interesting to me here is that what I wanted to talk about is that there's actually a space telescope, much like the Hubble telescope. And if you're unfamiliar with what a space telescope is, it's a satellite in orbit, either around the Earth or around the Sun, that we have launched into orbit. And of course, why would you want to put a telescope in space? Well, you don't have to take pictures through the atmosphere. The atmosphere obscures a lot of things we would see through a telescope from Earth. especially during the day, of course, because the atmosphere is blue when all the light from the sun is hitting it, and it's scattering that light all over the place and making it very difficult to see things. So having a telescope in space is very advantageous because you can basically use it all the time, and you don't have air in the way of making your observations. You have just the emptiness of space between you and the object, between the telescope and the object that you want to observe. So the Kepler Space Telescope was launched, I don't know, I can't remember exactly. I want to say within the last 10 years. And it surveyed the sky for several years. And it detected thousands of planets around other star systems. Thousands, right? I mean, we have 9 here in our solar system, but we have detected, again, with a pretty high degree of confidence, thousands upon thousands of planets around other star systems. In fact, they're all cataloged, and you can very easily just say list of Kepler exoplanets, and go to Wikipedia or any one of these other search results. Like you can go to NASA's website right here, Kepler's exoplanets.nasa.gov. Okay, here's some Kepler facts that I didn't know actually. So Kepler has been in space for 9.6 years. Of course, it will always be there. It will never be coming back. It'll just keep orbiting around the sun. It observed 530,000 stars, and out of those 530,000 stars, again, that's not all the stars in the sky. Those are just the ones that it observed, right? And we're going to find out in a moment just exactly what part of the sky Kepler observed, and that's the part that's blowing my mind. So 530,000 stars observed, 2,662 planets confirmed. So we found over 2,500 planets that are not within our solar system, right? That's just incredible, just amazing. Of course, it's done a bunch of other really interesting things. Kepler is 94 million miles away from us in its own orbit around the sun. 678 gigabytes of data. That's how much data Kepler has sent back to us from the other side of our solar system. That's interesting. This is an interesting fact in terms of fuel that it used. They're measuring equivalent fuel in gas. Of course, it does not run on gas, but the equivalent amount of fuel that it has used so far in order to maintain its orbit. It looks like about 3 gallons of fuel. So pretty interesting stuff. Anyway, you can actually find the entire list of planets. Let's see the science results. I think we can just go back to Wikipedia's page. Wikipedia has a nice complete list of all of the. Oops, that's the wrong link. A complete list of all the planets that Kepler has discovered, and it's huge. I mean, it is just an enormous list. I mean, look at the scroll bar on the right-hand side of the page here. I mean, it is just enormous. We can just keep scrolling forever. And so these are each one of the planets that Kepler discovered during its survey. Again, it's been in space for 9.6 years, a little under a decade. And so the part I want to point out that's really fascinating to me is the part of the sky that Kepler looked at. So this blob right here that's coming into view in the night sky, this is the area of the sky that Kepler observed. And you can see it's broken into 21 separate squares. So in order to survey, it can't look at the entire sky. It's impossible for any telescope we have to look at the entire sky and produce any kind of meaningful results. You have to kind of choose, you have to pick and choose what part of the sky are we going to look at, how long are we going to look at it for. I'm going to play this forward so that Kepler kind of comes into view. The Kepler survey area comes into view. Oops, right about, oh, that's way too fast. Right about there. So let's just take a look at it at its position in the sky right here, or maybe a little bit further. Right about there. So what's really blowing my mind is that before I knew that Kepler existed. I knew that Kepler was doing exoplanet surveying, trying to find exoplanets, and it's been super interesting to me for a long time. But what I didn't realize is what part of the sky, what percentage of the sky Kepler was even looking at. So let's zoom all the way out until the entire night sky kind of looks like a fisheye view for us, right? You can see the entire thing. Of course, we never see it like this. It's just what happens when you zoom all the way out. But it's crazy to me that those 2,662 planets that were discovered over here on this list of planets, all exist within this small little part of the sky right here. Just this block, this tiny chunk. And if you zoom out, you see how enormous the sky is. And then, I mean, we're just looking at one half of the sky here. If I take away the ground, take away the floor, you've got this entire other half of the sky that we don't see because we're living in the northern hemisphere. That's what people in the southern hemisphere see. People in Australia, you know, and other places that are south of the equator, they see in a completely different part of the sky than we do. So Kepler is looking at stuff that is only a tiny, tiny fraction of the night sky, and it contains, as far as we can tell, 2,600 planets outside of our solar system. Now, if you zoom in even further, you know, the thing about when you zoom in, when you're looking at a chunk of space, I mean, you can zoom out. It's like, oh, there's just, you know, there's black space in between these stars. Like, let's say between this star here and this star here, it's like, oh, there's a bunch of empty space right there. But if we bring that into the center and then we zoom in, we find that it is not empty. There's just more stars, right? And that's pretty much always the case. So between this point, between Atlas and I can't Fafnir, I can't read it right here, but between those two, Fafnir and Atlas or Atlas, whatever, there is like, I don't know, 20, 30 stars in between those two, and you can just keep zooming in. You know, there's a point at which we can't zoom in really much further because you kind of look as far back in time as you can. But I guess the mind-blowing fact for me today that I discovered is I did not realize what part of the sky that the Kepler Space Telescope was looking at. I just figured, you know, it's looking at the entire sky, or I guess I hadn't even considered what part of the sky it was looking at. It's just looking at this tiny part of the sky, you know, and it discovered 2,600 planets. And so by learning that, we can say, okay, if we know how many planets are in this part of the sky, and then we just multiply that times how much of the sky we have not looked at yet, there are just millions and millions and millions and millions and potentially billions of planets within just our own galaxy, because what we're looking at here is stars that are in our galaxy. Of course, there's other galaxies, right? Each of which contains an enormous amount of objects itself. So let's see. There's nebulous stuff. Yeah. I mean, I'm not going to go into that too much here, but yeah. The mind-blowing fact for me today was just the fact that this is the tiny part of the sky that Kepler looked at, and it didn't look at anything else because it just took that much time. It took, you know, a 10-year mission in order to survey just this part of the sky and confirm that there's 2,600 planets outside of our solar system.